Hello everybody and welcome to the third part on rules of derivatives. So let's summarize a little bit what we have done in recent hours and recent days. We have a few rules under our belt, namely we have that the derivative of c is known. We have that the derivative of x is also known. Combining both into c times x. This is also known. These we have seen, and this also we have seen in the first video for rules of derivatives. So I'm going to write them down and then we'll write the results. So we also saw that if we multiply a function by a constant, then something nice happens. And I believe the last one we saw in the second rule of derivatives video was f plus or minus g. Alright, so this is what we have so far. We're going to add on two more today, which will actually make the first half of the rules. And that will actually be the rest of what we need to learn this week. So what are those? The derivative of a constant, if you remember, the derivative of a constant is 0. The derivative of x alone, it is 1. And the derivative of c times x is just c. So that's oik. Oik. X to the n, the derivative is, we bring the exponent in front, we rewrite the x, and we subtract 1. The derivative of a constant times a function, the constant goes unaffected by the derivative, but of course the derivative itself is applied to f and f alone. As for this, well, that's the most intuitive thing. You can take the prime and give it to both. So you have f prime plus or minus g prime. All right. Good. So that is what we know as of now. Let us see if we can actually add a rule 7 to this list. Rule 7. Well, we have a rule for addition between functions. We have a rule for subtraction. So let's see if we can actually perhaps do something for multiplication. What is the rule, if any, for a multiplication of two functions? Please notice that this is actually different from rule 5. Why? Rule 5 is, yes, it's true, it's a multiplication, but it's a multiplication of a constant times a function. Here, we actually don't have necessarily a constant times a function. We have two functions of x. So, intuitively, I guess, what we would like to do is just take the prime and give it to each, right? So, wouldn't that be nice if it were f prime times g prime? Unfortunately, it is not. It is a little more complicated than that, but not much. This is f prime times g. So the prime goes to f, but not to g. And then we reverse the procedure. No prime to f and a prime to g. I am not going to prove this formula. If you are interested in the proof, you can see me during Zoom office hours, and I can actually show it to you. It's actually quite nice, but it's a bit too long. And the purpose is to be able to apply it. So, example. Evaluate the following derivative. So let's see, we have the derivative of, say, x3 plus x minus 1. That's going to be one term. And the other term, we could pick something like 1 over x plus the root of x. Okay, so we're going to put a little prime here because we want the derivative of this product. Notice that this is indeed a product because of the multiplication sign between the two. All right, so what we're going to do here is we're going to identify this as our F and this other guy as our G. So as you can see, we have an F times a G. So F is x3 plus x minus 1. And G is 1 over x plus root x. Yep. So what's the prime of this? What's the prime of this product? Let us follow our formula to a T. It goes like this. It goes like F prime times G plus F times G prime. This is my F. This is my G. So I am going to put F prime. What's my F? x3 plus x minus 1. So x3 plus x minus 1. And now I'm doing this guy. Okay? Now I'm doing this guy. Maybe a change of color, not to confuse anyone. Now I'm doing this guy. So this is F prime. This is this guy, which now goes and multiplies G, right? G, no prime. What is G? 1 over x plus the root of x, right? So what am I doing? F prime G, where F is x3 plus x minus 1, so this one goes prime, times G, which is 1 over x plus root x, which goes not prime. The sign in between is a plus. Plus what? Well, the function here is f times g prime. That's what the formula says. So I'm going to put f. F is x3 plus x minus 1. And then we have got to go g prime. What is g? G is this guy, right? So I'm going to go 1 over x plus root of x prime. Now, just to make sure that we know what we're doing here, this guy g prime is this guy g prime. Okay, good. All right. So, where's my black? So this is what the derivative is equal to. Obviously, there are some things for us to evaluate in here. Namely, x3 plus x minus 1 prime, we have to find out what that is. So we're going to need to basically invoke some of the rules we've already seen in order to figure out what this guy is. What is this guy? It's a bunch of functions separated by a plus or a minus, which reminds me clearly of Rule 6. What is Rule 6? Aha! Rule 6, you can give the prime to each. So that's exactly what I'm going to do. I'm going to give the prime to each. So there we go. x3 gets the prime, plus x gets the prime, minus 1 gets the prime, times this baby here, 1 over x plus root x. Notice, no prime, so I just rewrite no prime, plus x3 plus x minus 1, no prime, x3 plus x minus 1, no prime. Here comes the prime of 1 over x plus root x. What rule do you think we should be using on this? Two functions separated by a plus, two functions separated by a plus. So I'm going to give the prime to each one. So I am going to give the prime to 1 over x, and I am going to give the prime to the root of x. There we go. Equal, equal, equal. All right. Excellent so far. So let's summarize. It's a product, so we use the product rule, f prime times g plus f times g prime. Agreed? Okay. So maybe just here, this is f prime, this is g, this is f, and this is G prime. F prime, G, F, G prime. Good. Now what? Oh, well, what is this guy? X3 prime. Which of these rules would seem to apply for finding the derivative of x to a power? If you said rule 4, you're right. This is x to the n, this is x to the n. So bring the 3 in front, subtract 1, 3x squared. The derivative of x, rule 2. The derivative of 1, rule 1. So that's 3x squared plus 1 minus 0. Multiply by 1 over x plus root x plus x3 plus x minus 1 times, 1 over x, this is a division. I do not have a rule for division yet. I will by the end of this video, but I do not now. So 1 over x, I need to find the derivative of that. What do you think we should be doing? I don't have a rule for a division, something over something. But if I bring the x up, then I will have the derivative of x to the minus 1. And that I have rule 4 to help me solve. Plus, oh, we've seen this guy before, root x. Yes, that's x to the 1/2. So x to the 1/2 also needs to go prime. So, second to last, 3x squared plus 1 over x plus root x, x3 plus x minus 1, a lot of rewrite here. And here, that's where the action is. So x to the minus 1, we said rule 4. We're going to bring the minus 1 in front. We're going to get minus 1, x to the minus 1, minus 1. And that's x to the minus 2. Plus, again, x to the 1/2. Again, x to the 1/2, we've met this before. Rule 4, bring the 1/2 in front, subtract 1. And then I'm going to say that this could be my final answer. But it isn't. Why isn't this my final answer? If you said, because we still have some negative exponents in the picture, then you're absolutely right. See here, x to the minus 2 and x to the minus 1/2. That's actually an 8.5 on 10, if this is your final answer. Let's make it a 10 on 10. Final answer. Final answer. 3x squared plus 1, nothing to do with that. 1 over x plus root x, nothing to do with that either. Nothing for me to do with x cubed plus x minus 1, so rewrite. And here we go. I'm done with derivatives, but I want an extra step of algebra. So what is that? Can you help me out here? Minus 1, x to the minus 2. What shall I do with the x to the minus 2? Bring it down. So minus 1 over x squared. And I'm going to bring that down to plus 1 over 2x to the 1/2. And if you wanted to write x to the 1/2 as root x, you totally could. That would be entirely kosher. So you could do that if you want. So, yeah, that's it. That's my final answer. No negative exponents left. Everything is there. Wunderbar. That's an example of a product rule. So we have a new rule, rule 7, which is a rule for when we multiply two functions. Okay, pretty heavy whiteboard, wouldn't you say? So let's get rid of this and let's show you rule 8, which is on the agenda for today. 2, 1, gone! All right, so we'd like to introduce rule 8. So we have a rule for addition of functions, we have a rule for multiplication of functions, we just don't have a rule quite yet for the division of functions, so rule 8. So just to summarize, rule 7, the one we just saw, is f times g the derivative of that. And we just found out from the previous whiteboard that this is f prime g plus f times g prime. Good. So this is known as the product rule, the one we just saw. The product rule. Okay, so rule 8. Rule 8. Rule 8, the division. So f over g. F over g. We now have a rule for the division of two functions. This works almost similar to that. And also I will not give you the proof of this now. I prefer to actually spend our very valuable time on examples. So what is this? I'm going to rewrite exactly what I have above. So f prime g, and I'm going to put here fg prime. So is it the same thing with a minus? Not quite, but a little bit. The difference, or should I say the difference is, yes, instead of a plus in the product rule, it's a minus in the quotient rule, but it's also divided by g of x all squared. Okay, that's a weird rule, but basically it is the rule that actually works whenever we want to find the derivative of a quotient. That's called the division rule or the quotient rule. All right, like I said, I'd rather spend my time on examples than proof for these rules here. So let us see if we can actually find a nice little example for that. Let's evaluate the derivative of something like, what could we have? Doodah, x2 plus 1 over x minus 1, tutti tutti prime. Okay. All right. Here, I'm going to add a little remark. Simplify your answer. Many times, we want to simplify those derivatives to a maximum. Why? Because we use them for certain applications, and for us to actually be able to do the applications properly, we need the function in its most simplified form. So simplify your answer. So perhaps some algebra to be done on this at the end of the problem. But for now, let's take a look at what we have. We have a function over a function. This is really like I have here an f, and I have here a g, and this is f over g. So you see, if you want to compare that to f over g, you'd have to call the f x squared plus 1, and you'd have to call the g x minus 1. So you'd have to call the f x squared plus 1, and you'd have to call the g x minus 1. So I could put this down here if you want. And then we can apply the formula. F over g all prime is all this. So what's all this? Well, all this is f prime g and fg prime, just like the product rule, but a minus in between, right? So why don't I write the formula? So f prime g minus f g prime, all of that over g all squared. So let's go. F prime. F is the numerator of the fraction. F is x squared plus 1. X squared plus 1 prime. Times g, not prime. G is the denominator, and the denominator is x minus 1. Minus. Okay, we're down to here in the formula now. So f times g prime. So f, no prime. So x squared plus 1, no prime. Times, we're here now, g prime. Aha, g has a prime, so x minus 1 will go prime. All over g squared. So what is g squared? Well, g, like we said, is the bottom, x minus 1, like here. So x minus 1 prime. Not prime, sorry. Squared. Good. So, what's all this? This is now the prime of x squared plus 1. X squared plus 1 is the sum of two functions. The sum of two functions. That is rule 6, f prime plus g prime. So here we go. X squared prime plus 1 prime times x minus 1 not prime minus x squared plus 1 not prime. And here comes another dude. X minus 1 prime, well, it's a minus in between the terms. That's rule 6 again. So this has to go x prime minus 1 prime. Tutti quanti, everything over x minus 1 squared. Good. So, what rule shall apply for x squared prime? Rule 4, x to the n. That's 2x to the 2 minus 1 plus 1. What's the derivative of 1? It's a constant. The rule for the constant is rule 1. So plus 0. Times x minus 1 minus x squared plus 1. And here we go again. X prime. Well, that is rule 2. It's 1. Minus 1 prime. That is rule 1. 0. All of that jazz all over x minus 1 squared. Notice that all the derivatives are taken. This second to last line still has some primes in it. Here and here and here and here. This last line doesn't. So if the problem was like just don't simplify anything, then this would actually be a valid final answer. But in here, we need to actually come up with a little bit of algebra. So we need to simplify our answer. So let's do that over here. So just that I don't have to do another whiteboard just for the algebra, I'll just do that over here. So we're going over here for now, and we're just doing algebra. All the derivatives, they are done. So 2x plus 0, that's 2x multiplying x minus 1, right? 2x plus 0 is 2x times x minus 1 minus x squared plus 1 times what? Well, 1 minus 0 is 1, so I don't even really need to write it down. All over x minus 1 squared. Now let's stay away from silly mistakes. Am I allowed to cancel this x minus 1 and one of the x minus 1 downstairs? You may be tempted to do that, but it would be wrong. Why? Because there's a minus here that actually links those two guys. So unless the x minus 1 is factored out in front, there is no possible simplification here. So let's not do anything silly. We're just going to leave this like that and continue the proper simplification of this expression. This is going to be 2x squared, baby, minus 2x minus x squared minus 1. So what did I do? 2x times x, 2x squared. 2x times minus 1, minus 2x. Bring the minus in the bracket. Minus x squared, minus 1. That is the proper way to simplify this ugly thing. All right, I believe we might be ready for a final answer. Collect like terms, 2x squared minus x squared, that is just 1x squared. And then minus 2x, and then minus 1 over x minus 1 squared, and that's a final answer. Maybe some of you are thinking, hey sir, you could actually do something with the numerator. You could factor this. I got news for you, that doesn't factor. It doesn't factor because this, instead of being a plus 1, is a minus 1. So there's no nice factoring for this. This is my fully simplified answer for this problem. Okie doke. All right, so when we meet on Zoom, we're obviously going to do more examples of this nature, but I do have time to do one last quickie with you guys today. So we're just going to get rid of this, and we're going to do one last example. Okay, so what could we do as an example here? What about something like this? Example, evaluate the derivative of, let us see what we could have here. We could potentially have x squared minus 1 over x minus 1 prime, like this. All right. So this totally look like a division, no? Doesn't this look like a division? Doesn't this look like this is an F and this is a G? Yeah? So we are ready to apply rule number 8, the division rule, unless you tell me otherwise. Are you telling me otherwise? What am I hearing? Really? You think? Factor the numerator? Huh, that's a brilliant idea. How brilliant is this? That is a brilliant idea. How much will this simplify the problem? Holy moly. X squared minus 1 is x minus 1 times x plus 1. Difference of squares. We know this. Ha! Look at that, baby. Look at that. Holy moly. Holy moly. So if x is actually not equal to 1, so provided that x is not equal to 1, we can come up with this simplification. How lovely. Look at what we got. Instead of a division rule now, all we have, it's almost a joke. It's almost a joke. It's x plus 1 prime. Well, what rule are you going to use for that? If you answer rule 6, the plus rule, you are correct. So this is the prime of the first, and the prime of the second. This is rule 2. This is rule 1. Who would have known that the answer to this derivative is simply 1? So the point of this example is simply, if you can do a simplification before hitting the derivatives, you will actually save yourself a whole lot of hardship. Could you imagine doing this using f prime g minus f g prime over g squared? It'd take me like a lot more space than that. For what? I would get the same answer in the end after a lot of simplification, right? So, if you can simplify before hitting the derivative, do so. There are obvious advantages in spending a minute and trying to simplify. Good. So we'll erase this and we'll summarize the lecture today. We have added 2 rules to a list that now comprises 8. So what are these rules? Summary of what we have learned this week in rules of derivatives. Rule 1, the derivative of a constant. Rule 2, the derivative of x. We're starting to know these, right? Am I wrong? I think we're starting to get a feel for at least the first couple. So x to the n. So these were the first 4. So 5, we have k times f of x. And then we have f plus or minus g, my good old addition or subtraction rule. The ones we added today, we have f times g as well as f over g for rule numero 8. All right, so I'm just summarizing these so that we have them in our notes in one page. So we only have to turn to that one page when we are working problems on Zoom. So what are those? So what are those? So what are those? All right, so derivative of a constant, derivative of x, derivative of c times x, oik, x to the n x to the n minus 1. A constant times a function, the constant may go outside while we derive only the f, not the constant. The derivative of a plus or a minus, you are allowed to give the prime to each. An easy rule. F times g, you are not allowed to give the prime to each. It's another rule. It's f prime g plus f g prime. And then I will erase those little ink marks on the whiteboard to come up with the last one, which is so similar to the product rule. So no, you're not allowed to give the prime to the top and the bottom. We are rewriting our product rule. We are actually changing the plus to a minus, and we are dividing this by g squared. By g, got the weird g. See if I can do a better job with a g of x all squared. So this is where we stand thus far. That's going to be enough for today. So we'll meet on Zoom and we'll practice these some more. We'll do more complicated problems. So see you out there, and you have a good day for now. Bye bye.